Hi, welcome everyone, and welcome Paul. I'm very very happy to have you here. Paul is the founder of MetaGeo. Welcome, Paul.
Thank you very much.
So Paul, so today, like in this interview, what we're going to do is I'm really really excited to learn a little bit more about your personal experience. You have knowledge and experience in the aerospace, in the aviation. Very happy to hear a little bit more about how did you ended up to create MetaGeo, which is basically a 3D map and hosting, visualization, and management platform for mainly for aerial images. So, Paul, I just want you to share like a little bit more about your background in the aviation to start. And happy to have a follow-up question for you.
Well, yeah, I've been working in the kind of mapping and aviation space, aerial imaging for the past about 10 years. But I really got into it when I was younger. I got into model aviation when I was very so back when we would build model airplanes out of wood and put gas engines on them and have rudimentary controls. That's really what kind of bred my love for aviation of all types. And when I was a kid, I would go to the library and I would buy every book on aviation that I could. I would come home with a stack of books this big every time I would go to the library, and they actually put a limit on me as to how many books I could check out at once. So I was really fascinated with airplanes since I was a kid, and I really wanted to be an aerospace engineer. And that was before I couldn't even really spell aerospace engineer. I didn't actually go that path. But I did end up in aviation eventually. So I was a paramedic, and I joined a helicopter team out of the Bay Area, so San Francisco Bay Area. So I was a flight paramedic on a multi-role law enforcement helicopter that was with the East Bay Regional Parks. So did everything from medical to law enforcement to firefighting missions. And unfortunately, I had to medically retire. I went back to school, and when I was studying earth biology, I was asked by a professor if anybody in the class was familiar with model aviation. I said I was, and I said, well, we're strapping cameras to model airplanes and taking pictures because the cost to do this with a traditional aircraft is tens of thousands of dollars. And if we could put a camera on a model airplane and be able to take the photos, it saves the university a lot of money. And so I did
Yeah,
that and ended up running and teaching at the university, basically training students and faculty how to not only build, because this is before drones were kind of prevalent. And so it's build and actually attach cameras, get the data, create maps, and then later that progressed into drones and 3D scanners. And from there, I went to go work for a drone mapping company called Pix4D. And what they do is they take photos from drones or really from any camera, so aviation, satellite, handheld, and they use that to make 3D models through a technology called photogrammetry. And so I worked at Pix4D. It was a Swiss startup, and I was the third employee in the US. So I went on to lead that. We had a really awesome training team, did a lot of really cool projects in aviation with drones, with airplanes. Went on to work with the Intel Corporation, where we did a lot more. So we were actually developing our own drones there. And then along with the software to control it, to also they were working on drone shows, which is thousands of drones flying at once in the sky, making 3D representations, kind of like fireworks. So you can have basically an LCD screen in the sky with thousands and
yeah,
thousands of drones up there. And so, yeah, it was awesome to be a part of that. Went on, and then I got a little bit more into the virtual reality aspect of things, using data that's from aerial cameras to make 3D models for virtual reality. And actually did a project with the Olympics where we 3D scanned parts of the Swiss and French Alps. And then those were Olympic venues, and we made it so people can actually take that mountain that we 3D scanned, put it on their coffee table, and be able to experience the games in a brand new way. They can actually press a button and see a video camera of, from on the track. So you can look around and watch the skiers go down the mountains, go over jumps, as if you were actually there. And so really this culmination of aviation and mapping technology brought me to MetaGeo, which is, there's so much data out there, and drones have been revolutionizing the aerial imaging world because they are a cheaper and a very effective way of getting really granular data. It's the right tool for the right job. Traditional aviation is really great for big areas, Drones are really great for small areas and super high detail, but then you have satellites, which are really great for super wide areas. But there's a level of detail, and it's the right tool for the right job. Uh,
Mm.
MetaGeo came out of having all these different sources of imagery and all these different sources of maps. And really, I found it hard to share just these massive data sets that come from airplanes, helicopters, drones, because as you're starting to collect more and more data, you need a way to be able to display that. And it's been to the point where in the industry for aerial imaging, you're talking about so much data, it's like petabytes, and to understand petabytes, that's tons and tons of data to the point where people are actually having to ship that data to places to get it there faster than internet speeds can handle.
Mm.
And so MetaGeo
So
is a platform to be able to help host, share, and distribute that data.
so how did you basically find this problematic and the fact that um, it was missing a software platform in order to be able to host and analyze that data? At what point in the process, like in your experience, you say like, wow, this is a great idea. There's like a missing piece within like the chain, and I want to
Mhm.
work on it, and I want to just grow that.
Yeah, throughout my career, I've worked with lots of different companies, from construction to land management to cities and even countries. And so one of the issues that I continually saw, both through my positions and also after until I did consulting as well. So through my different positions and through my different experience, I realized that a lot of these companies have trouble sharing the data. Even one of the largest aerial camera, I'm sorry, manned aircraft or crewed aircraft camera companies, they have their one sensor, and just one data set from one flight is an entire hard drive of data. So in order to be
Mm.
able to share that, like I mentioned, people are having to ship hard drives, but we make it so you can upload the data easily and quickly, and then be able to share that data. So when you're looking at it, you also have to have specialized software to be able to view it. And so typically, if you're not a specialist in this field, you'd have to go buy very expensive design software or mapping software that could cost quite a bit. And so this kind of solves the problem of, one, how do they easily get the data, but then two, how do they easily view it? Now, more advanced users, of
Mm.
course, will already have the design software. But if you have, the CEO of a company who needs to make quick decisions based upon, land conditions, if there's flooding and a government entity needs to understand where damage is or a fire, it really gives the ability to give more people access to data that might not be an expert but still need to have information.
Okay, so let's start from just like to try to understand like the different use cases that you have in that space, and I'm as well
Yep.
like interested to understand like, I mean, we're going to discuss as well on the drone innovation. That's all the innovation brought by, I mean, drones in general. Like, how does that impact like the market? But first, I would say like before the impact of the drones. And that's basically like what you were doing, like within your consulting company. You were helping different companies to fix and set up different hardware equipment to basically collect that aerial data from a traditional aircraft or helicopter. Can you just like walk through like the different type of use case that we have in that industry and space?
Sure. Yeah. So, I mean, as I mentioned, it's the right tool for the right job. Drones are really great for kind of, I call it more of a microscopic view. And traditional aircraft, airplanes, helicopters are better for a macroscopic view because there's weight and line of sight considerations when it comes to drones. So you can only fly a drone without special authorization as far as you can see. So the drone, if you're say doing a few square kilometers or a few square miles, it's going to be very difficult to maintain line of sight on a drone unless you have, again, special authorization, which you can apply for waivers with the FAA to get that authorization, but it requires special procedures, special equipment, special training, and a complete description of it. So that's a lot of work, and some have actually been able to obtain that with some great results. But when you get bigger than a certain size, it doesn't make sense to use a drone. And so when you're using a more traditional aircraft, it's easier to do things like fly over a city or fly over an airport. Whereas when you have drones, there might be a TFR or there might be some sort of restriction that causes you not to be able to fly a drone there. And then you have to apply for the permission to do so. Now, with more traditional aircraft, you have less of those barriers. And so it's really the right tool for the right job. And let me give you some examples of kind of when you would use what and for what purposes. So one of the most recent use cases I was working with Phase One, which is a company that does they make amazing cameras for crewed aircraft. So around 100 to 880 megapixels. And so to put that in perspective of scale, if your cell phone image was your standard out cell phone image was compared to this, it's about 10 to 15 times higher resolution for the lowest of their cameras in your phone. And so on the Pass 880, which is a big one, it's actually got multiple cameras looking in multiple different directions. And so you can really take big swaths of data with just one flight with an airplane. And so with one of their 150 megapixel cameras, they were flying over a golf course to be able to understand kind of what's the condition of the golf course. And one of the great things with aerial data is it's like a snapshot of time. And there's so many use cases that you have with that data. You can find, okay, what's the condition of the greens? Are they healthy? Are they unhealthy? And it's that period of time, and you can compare it over next season. So next season, you can compare the data from last season to see, is it getting better or worse? And you can say, okay, were we using the right fertilizers? Were we watering it enough? You can start to do some of that analysis. And then other things you can do with it is, if you're making 3D models of it, you can understand the topography. You can understand where the low points and the high points are. You can see, okay, if we have a flooding event, where's the water going to go? Or if we're putting in new irrigation, how is the irrigation going to be affected by the slope or the size or the distance that it has to travel? So those are some of the base things you can do. And then when you're getting on the more granular side of things, say that we have a power company and they have 100 miles of power lines that they need to inspect. And oftentimes you'll have trees, construction, lots of different things that could potentially impact power lines. And so they'll regularly go and go inspect long swaths of power lines. And so depending upon what information they're trying to gain from it, whether it be vegetation encroachment, meaning trees growing too close, which causes a risk of a tree falling and hitting the lines, or if they're trying to inspect the individual pieces of equipment on it, that's where you kind of might potentially make a distinction between flying a more traditional aircraft or a drone, because as I mentioned, the drone's more like a microscope. So if you need to get up and you need to do a really close inspection of, say, like maybe an insulator has damage or it's been flashed over, a lot of the times with the higher resolution cameras from like say Phase One or whatever's flown on a more traditional aircraft, they're able to get the photos, but they're not often able to stop and then go like orbit around something. And so the other thing they're not able to do is get down underneath. So if you need to look up, that's a place where a drone would be the tool to use, because you can get in between the lines, nice and close, and get high resolution imagery of what you are interested in inspecting. And then that makes it so you don't have to have somebody with rope or with high lift access, meaning that you're not putting a person up there in danger. You're using the drone as a tool to be able to reduce the risk and improve the safety of the workers. And so that's a
Okay.
really great use case of when you would choose one or the other.
Okay, and in terms of so we understand like the different type
I
of
think it froze.
aircraft depending on the type of jobs that you have. But what about the type of industries that requires those type of services? I think that you mentioned as well, like construction, in order to being able to analyze what's the difference. I mean, how is the evolution of a specific construction site from a specific time to another
Mhm.
point in time? But what other industries typically have those type of needs?
Yeah, so architecture, engineering, construction, so AEC is one of the large ones. DOTs and transportation, so anything having to do with infrastructure, bridges, roads, highways, they'll need that information as well. And then insurance, of course, if you're doing property insurance or agricultural crop insurance, having that before and after picture helps them understand, what damage took place. Also using it to prevent fraud, to understand, was this damage occurring because of a storm that happened, or was it damaged afterwards, and then maybe there was a fraudulent claim filed. Liability. So on the construction side, they'll typically will document before, during, and after. So in case that they're building a construction site and there's damage to an adjacent property, they'll have the proof that they didn't cause the damage, that it was there before, or if they did, they'll have a record of it. And then
Mm.
oil and gas, energy. There's really a ton of different applications: public safety, search and rescue, and a lot of
Yeah.
environmental management and consultation.
Okay, so and so if we focus again on the introduction and the development of the drone technology, so really like what this technology has been introducing like within that space is really um, first the capabilities to being able to I guess like there's a cost differentiator between like flying an helicopter I guess and a smaller drone. What's how did that in technology just like innovate and revolutionize like these specific market segments?
Yeah, so as I'd mentioned, before, in order to get a basic collection from an airplane or even a helicopter, you're talking about, tens of thousands of dollars. And now with a drone, if it's a smaller area, it could be hundreds of dollars or thousands of dollars. So it's reduced the price significantly. Of course, that's within a small area that the drone can cover. Of course, if it's going to be a bigger area, then you need to have a bigger tool for that job.
Mm,
But specifically, the innovation with drones, I mean, it's improving safety because it's doing things that they wouldn't even consider flying traditional aircraft for. Like if you're doing a roof inspection over just one or two roofs, there's hardly that they would ever consider to use a traditional aircraft for that. There are services that do regularly collect that data and do make it available, but the granularity sometimes is, not quite enough. Like for example, you might be able to see that there's damage on a roof, or that there might be, some sort of discoloration in a facility, like the lining of, a piece of equipment. But you wouldn't be able to see the true detail unless you had something that could get closer. So it's really enabled people to get places that were much harder to reach. And then from the kind of the not just pure aviation, you can actually fly drones inside of things. So if there's
mm,
a tower that has some sort of component inside of it that you need to check, you can fly a drone into it, or a tunnel, or like a tank, or a furnace. You can fly drones into places that you couldn't get a traditional aircraft. So it's really made it much more accessible to a lot of different industries, especially inspection. So if you think about like big smokestacks or big furnaces that they have at different kinds of plants facilities, you could actually fly a drone up the tower and into that area to inspect it when it's turned off. Whereas it's going to be really hard to fly a helicopter and be able to get that close and be able to get the camera angles necessary to do that inspection. So they would just send somebody up with a rope, and they would climb up the tower and have to climb into these dangerous areas. So it's really improving the safety.
okay, so right now with metageo, the problem that you're solving basically is that previously I would say like companies that were flying like those helicopters, those drones that was like trying to um, just get the images that they need for their specific application and use case. When they were sharing that data, they were just like sharing that data like within like a platform that was more difficult to use, but at the same time like it was more like local environment versus like having that like hosting on the cloud. Do you what other like benefits then I would say like does your platform provide to that specific industry, and what kind of new usage do you allow to create here?
Yeah, so the biggest problems that we're trying to solve with Metageo is that one, data is really big and hard to transfer. So that means that we're trying to make it so it's cloud-based. And so sharing between teams is much easier, because typically what would happen is companies that are collecting this data, it would go to some specific engineers and stay on a hard drive locally, and not be easily shared from that engineer to different parts of the business. Now, it's being broken down a little bit, but the software that those engineers is using is quite complex. So it's very expensive. So we're talking about CAD drafting and design software, or GIS, which is Geographic Information System software, both which are thousands of dollars for a licensee. And then also it's very technical. It's like, if you'd never worked in graphic design and you opened up Photoshop, there's all these buttons, you don't know what they do. So it requires an actual
Mm.
fair amount of training to be able to be proficient at these different platforms. And so we want to make things super easy to use. So it's powerful enough that those users who still have to do their work in those software can then push it out and then share it on the cloud easily. And the other part of it is that with these different types of data, so laser scan data, which comes from aerial platforms, so drones or traditional aircraft, but also visual spectrum, so RGB or infrared, near infrared, multispectral. There's all these different camera type sensors, and each different one has a different file format and a different set of software that you need to open it or to interact with it. So there's not a lot of combination of data because there's all these different formats from all these different sources. So we make it so you can easily combine, your aerial data from a helicopter with your drone data, with your ground-based data from your mobile phone, and then also overlay some satellite data with it. So we're combining all these different data sources and being able to visualize it in one three-dimensional world.
Okay, so as of right now, the use case is really like each customer or each company will have their own environment versus like an environment which is populated by data from anyone. It's just like more that their own environment that they can use and share the data with different stakeholders. Anyone can access and basically use.
Yeah, absolutely. So today, the platform is there's a free account which allows you to kind of host some of your own data, but the majority of our customers today are going to be companies that want to keep their data private. And so they'll be able to have their organization with a number of users. So they'll have an administrator who adds and removes the users from their company account. And then they'll be able to state who has access rights to different types of data. Like, for example, if you're one of these companies and you have contractors, maybe you don't want your contractors to be able to see all of your data. So you can give them only upload privilege. So they can upload the data that they collect in the field. And then your designers or your executives can have more of the read-write access where they can have the ability to actually view the data, to leverage it, and that's all private. And there is a way to share it outside of the platform with a simple link, but you can set expirations and you can set limits on those external limits. Now, going forward, we want to be able, and actually, let me back up a little bit. So one thing we're also building is a library of public data. So a lot of different agencies, like government agencies or organizations, they'll collect data, and oftentimes when it's paid for by taxpayer money, they have to make it public, or they're just publishing open source data, which is crowdsourced. And so we're building a library that people can easily access some of those data. So it's not going to be that we're selling it; it's that we're giving people access to those resources that already exist for free, because oftentimes they're hidden behind a really old website on some government webpage somewhere, or it's some place that you might not even think about looking. So we're creating a way to get public data and be able to compare it with your own data. And then to the public data source, we want to be able to have our free account be a way that people who are just kind of getting into this industry, or they're advocates, or they're really just interested in contributing to a public data set, will have a data set that you can contribute to and upload for free, and we'll host it for free. But then it becomes part of this living community-based data set. So that would be super interesting, especially because this data, map data, you think about it just being, like a Google map, but it's much more than that. When you go and you walk down the street, every building has information assigned to it in GIS somewhere. So there's going to be, the property, the taxes, the owners, everywhere around us is this data layer that we can't see. And so having a way that is easily communicable through public sources allows us to kind of unlock that, be able to understand the data that's around us. And so having that public data source, you could build things off of it. Like you can, go do design and build it off the latest data that would be from multiple different sources.
Yeah, because you were telling me that, I mean, potential individual, I mean, a private owner of a specific individual use cases, such as like a private owner of a house need, for example, to do like any type of remodeling on his house, and is interested to, for example, to understand like what is the calculation of the surface on the roof. With that
Mm.
data, or just like try to build like an extension on the house or things like that. I mean, with that data, you can simply get like pretty accurate modeling from that data, and use that. There is like different use case that, I mean, anyone can basically do.
Yeah, so it really depends on what accuracy level you need. But the amazing thing is now we carry, this complete sensor platform in our pockets. We have, this thing which has a 3D scanner on it. iPhones now have LiDAR on it. It's not the most accurate, but it's accurate within a few centimeters. And so sometimes that's enough to get, a general understanding of the size of something or the scale of something. So to your point, like if you wanted to go in your backyard, pull out your cell phone, 3D model your backyard, then you'd be able to get the dimensions of which to build, a new garden, or planter boxes, or figure out how many paving stones you need to use. So there's more kind of real world kind of consumer type applications, and it really just boils down to what accuracy you need. Now, if it's going to be more of a survey, then you have to involve a licensed land surveyor, and it's got to have quality assurance checks. Like it has to have X number of points, X number of accuracy using survey markers and that sort of thing. But it just depends on how accurate you need to get it. But we'll take in all that data.
Yeah. Do you need to have like a LiDAR necessarily if you want to get like any 3D mapping, or just like if you fly your DJI drone with a commercial camera, you can actually have that 3D mapping?
Yeah. So as I'd mentioned before, photogrammetry is kind of the art and the science of using photos to make 3D models. So there's a lot of different softwares out there. Reality Capture has a software called Reality Scan. Um, and they have an app that goes on your phone that you can use photos to make 3D mapping. Then there's other ones like Polycam, which is another phone-based one. There's Luma Labs AI, and then that's more on like the mobile phone. But then on the larger scale, for like using drones, there's Reality Capture, Pix4D, Bentley Agisoft. These are all different softwares that will take photos that have overlap, and because of the different positions of the photos, it's able to triangulate where each pixel is and then create a 3D model by building all those points in the different pixels from the different camera angles and overlap taken. So it works a lot like your eyes do. So we have two eyes, and therefore we're able to triangulate how far away something is. And so if you can imagine each camera as an eye, and now you have cameras in space that you can then triangulate the points in each pixel, you start to build kind of the shape of objects, and you have the color information from the camera. So then you can colorize it and kind of wrap the picture around that 3D model like a blanket, and then make a photorealistic 3D model. So it's really
Mm.
cool, and they're starting to use that for video games, for simulators, for um, tons of applications, movie special effects, inspections, architecture, and the list goes on.
That's great. I mean, I can definitely like see the future where, I mean, the more and more drones, because actually the drone is the I think will have like a huge impact, because first, it's, as you say, like it's very easy to fly. You can
Mm.
fly very often, and that can just upload like a large quantity of data, which can be then used by so many different companies with different use cases that can use that data if they have obviously like the right platform and analysis tool. How do you tackle privacy if you have more and more data from those different users? How do you tackle privacy, for example?
Well, so there's a few things, and this is kind of controversial when it comes to drones and privacy laws, because, well, first of all, when you think about a drone, a lot of people have a really negative kind of reaction to that, because there's been a lot of people who have felt that, someone's flying a drone over my backyard and my daughter's out in the back in her bathing suit, or someone's flying a drone near my window and they're spying on me. Um, there's a lot of people out there that feel really threatened by drones. And I think as part of the aviation industry, it's our duty to really make sure that people are following the rules, but also educating others on what's possible, what's not possible. And so with drones, of course, you don't want to have someone hovering over your backyard or in your private space. Now, there's rules that prevent drones from actually flying over people. That there are waivers for like special events, and that requires special equipment and following certain rules. But when you're flying a drone and you're high up in the air, it's actually quite difficult to make out what people are doing. And so letting people know that, hey, I'm flying a drone in this area. I'm not looking at you. Take a look at the screen. This is what you can see. You're looking at a small little screen about that big. It's you're not able to capture a lot of fine details until you review the photos later. But people feel like you're just in their airspace, and they feel like their privacy is being invaded. So one of the biggest things that we always do when we're doing drone operations is not only do we check and do all the airspace clearances and make sure we're following all the rules, but we'll oftentimes go to a neighborhood if we're going to be doing commercial operations and let them know ahead of time. Like, hey, there's going to be a drone flying overhead. We're not looking at you. We're going to go inspect the power lines behind your home, and we're not going to be on your property. That sort of thing. So that goes a huge distance in building more public trust. And then on the privacy side, with regards to, can someone take a picture of my backyard from the air? And the answer is, it depends on where you live. But most of the times, the answer is yes, they can, as long as they're not targeting you specifically. And again, it varies from city to city and state to state and country to country. But there are rules about, keeping toms and privacy. And of course, if someone's harassing somebody, there definitely needs to be something done, and that's the law enforcement issue. But the other thing of it is that when you think about having your backyard, you feel like it's an enclosed space. You have some expectation of privacy because you have a fence. However, if you also think about the fact that there's satellites that are taking images of the Earth every square inch every single day, um, that privacy outside of your home, like there's photos being taken of your backyard on a regular basis. So what's the difference of a drone taking a low resolution photo, which might have some of your backyard? And I think a lot of it comes down to the intent. Obviously, I think it's the responsibility of drone pilots to be, knowledgeable and to know the rules, to follow the rules, and also to just not push people. It's a professional and ethical thing where you don't want to be purposely pissing people off and make them hate drones, right? Because then the other day, one of the crews that I work with, someone pointed a shotgun at their drone because they thought that they were flying over their house, but what they were actually doing was inspecting a water reservoir. And so they weren't even
Yeah.
flying over the house of these people. It was far away, but they felt so threatened because of what they've seen or potentially past experiences that they feel like their privacy is being invaded. Now, when you come to
Mm.
the data part of it, that's another thing. When you take a photo, you're the one that owns that photo, but it might be of someone else. And so, in certain circumstances, you may have to have permission from those parties to get imagery. Especially in different countries, there's a lot of rules about where you can fly the drone and where you can't. In the U.S., the FAA controls the airspace. In different areas where there's a civil aviation authority or some similar agency to the FAA, some places require written permission from the landowner to fly over it. Whereas in the US, technically the FAA controls everything that's in the air above the ground. So it varies based upon the jurisdiction, but then when you're uploading data to places, there's a lot of concerns about privacy, like where's my data going? And there are privacy policies that companies have to have published that kind of describe what they're going to do with data. And a lot of people have concerns about putting data on the cloud, and that's a very valid concern because there's hackers that could break in and take the data, or is the company going to sell our data? And so it really comes down to the platform and what they're doing. And with MetaGeo, currently we only handle data on a private level. So that means that we're not sharing things publicly unless someone specifically shares it. When we have a public data set, that'll be different. Then there will be like public domain rules, but we haven't quite gotten there yet. And so, I mean, as a rule, we're not taking the data and doing anything other than we might need to work on it to get it to work correctly, or we might need to with your permission uh, run an analytic on it or do something to it. But we're definitely not very lax when it comes to dealing with people's data. Of course, if it's private, it's private, and we definitely understand that. So when it comes to the more broad kind of like data, there's open source data that's out there, and the ones I was talking about in the library. Each of those also have rules about how you can use it and where you can use it and how you distribute it. So yeah, there's a lot of components to privacy and data, and I can't even just scratch the surface on this call, but yeah, it's something it's really important. And the downside to having stuff on the cloud is, yes, you can have it be taken over, or you can have servers that are taken down, or you can have servers that are people break in and steal data. However, that can happen on your regular computer as well. And so if you're connected to the internet with a computer, there's still risk there as well. So if you have a computer that's completely offline, there's definitely use cases where that absolutely should, especially when it's something like national security, or if it's something that's super sensitive, like power plants or that type of data. That of course absolutely should be as safeguarded as possible. But it really depends on the kind of data and really the risk that goes with it.
That's I understand. It could be like a big concern. There's a lot of discussion around that topic. It's a topic which is difficult to solve, obviously. But it's always like you need to keep an eye on it and adapt depending on the use case. But it's for sure, like with the market evolving with toward like like more drones, more image, more data. It's a topic which is always like coming on this side.
Yeah, it's going to be constantly evolving, and I mean policies evolve too with it. I mean, you're talking about all the airplanes and drones flying overhead all the time. I mean, the imaging of Earth is only going to increase. I mean, there's going to be more satellites up there. All the different drones that are going to start doing shipping. Like a lot of those drones will also be collecting data as well as they're flying to their locations to drop off packages.
Yeah. Yeah, absolutely. Do you currently get like images from satellites as well?
Yeah. So when I first started working in environmental science, GIS is like one of the main mapping tools, and it was mostly satellite data with some augmented aerial data, and then drone data started coming around. So now it's like combining all these different levels. And if you can think of satellite, the resolution limits, there's like there's physical and then there's legal limitations onto the resolution of satellite imagery, and then that's kind of removed by traditional aircraft because they can fly lower. So typically, from in satellite, you'll have around 30 centimeters per pixel, which means that every pixel occupies 30 centimeters of space on the ground. And then airplanes are usually, anywhere from about 30 to 3 or 4 centimeters per pixel. And then drones could be millimeters per pixel, depending upon what camera and how close they are. So, like I mentioned, that's kind of the drones are more like the microscope versus satellites, and aircraft are more like the macroscope. So, and there's price variance as well, right? Because if you have satellite data, it's a little bit cheaper because they're casting such a wide swath. But if it's super high resolution satellite data, then it can be more expensive, and it depends if it's imagery or radar or thermal. There's different components to it. But yeah, satellite data is kind of what I would say is like the foundation of the Earth observation. And then the traditional aircraft are kind of like the tools to get a large area and higher resolution, and the drones are smaller area, super high resolution.
What's the price tag like we're talking about between like satellites, aircraft, drone? Like, can you share like some price difference?
It really varies. I mean, I've seen satellite providers that charge, a few $1,000s per square kilometer, and then for a traditional aircraft to do a few square kilometers or a few square miles, it would be a few thousand. Um, and then when you're talking about a drone, if you're trying to do that big of an area with a drone, and actually the price goes up quite a bit because
Yeah.
you're limited by how far you can see. So a crew that's flying a drone trying to capture the same amount of area that, say, Cessna would, that drone crew would have to move like 10 or 15 times to be able to maintain visual line of sight. So that
Mm.
means flying the drone, packing it up, driving to the new location, unpacking, flying. And so that turns a job that a Cessna could do in like 1 hour to a job that a drone would take a week to do.
Mm. So
Now,
it's really like
that
the
will,
surface that you have.
yeah. And so one thing I would say is that with with the drones, as visual line of sight becomes less of a requirement, drones are advancing rapidly. They have been. I used to say that drone years are like dog years. One year in the drone industry is like 5 years in any other industry because of how fast the technology is basically evolving. And so, as the obstacle avoidance technology and the awareness, like the flight, uh, basically the detect and avoid, which is detecting aircraft and avoiding the systems, become more prevalent, and there's transponder, like remote ID, that's actually required on all drones now. As that progresses, and as aircraft are able to better share airspace by understanding the positions of drones, you're going to see more beyond visual line of sight operations for drones. And once that happens, there will be an increase in that range because a lot of that limitation in the range with drones is based upon regulations. Because they can make drones that can fly for 20 hours, without a pilot. And so the problem with that is once you introduce that to national airspace, you have to have everybody aware of what that drone's doing. It has to have the capabilities of detecting hazards, and if it has a pilot, they need to be able to to have the range and the control over it to be able to avoid issues. So there's still things that need to evolve with technology as far as making those different kinds of equipment standard on every drone, or maybe that just for specific applications. But once it's more commonplace to be on visual line of sight operation, you will see that there'll be better utility in the drone space, and it will start encroaching more on the crewed aviation. But for safety and for just having complete control over the national airspace, I think right now it's getting there, but it's not quite there yet.
It makes sense. How do you guys? What's your next steps, and how do you guys trying to adapt to that changing market demand? Like, what's your vision and strategy on your side?
Yeah, well, we're definitely platform agnostic, and that's kind of what our strategy is going forward to working with different kinds of data, different kinds of analytics on that data, incorporating new technologies such as AI, and then also, really kind of supporting the companies that are building this technology. We really want to be able to help out, with providing map data, with providing ways to leverage the data that comes from the drones or from the traditional aircraft. And so our vision for the future is really just being as interoperable as possible. And we will see drones that will be able to fly beyond visual line of sight pretty soon. I'm not sure if that's 5 years or 10 years, but once that happens, then there will be a pretty big shift in the market for traditional aircraft because it's going to start encroaching on that market a little bit more. However,
Mm.
I still see that there'll be a great need to have more traditional aviation because there's a lot more control over it. So more sensitive areas I could see becoming the area where traditional aircraft shine. And then with more hazardous up close areas that I could see the drones being a lot more utilized because, you don't have to put a bigger aircraft with, human inside of it at risk. And so
Mm.
anyways, our goal is to be able to support any kind of level of remotely sensed data from any kind of aerial platform. So that's really our goal, is to be able to kind of help those technologies grow and support the data and the volume of that data that comes, because there's just going to be more and more data that comes from these different platforms. And the cameras are getting
Mm.
smaller and smaller and higher resolution. Um, so that means more and more data.
Thank you so much, Paul. It was like really insightful to just like discuss and for you to share this story with us. I really enjoyed. Um, how can people
Great.
reach out to you to get more information or to get in contact with you?
Yeah, so if you want to check out the software, there's metageo.io, or you can find me on LinkedIn and add me and start up a conversation.
Sounds good. Thank you so much, Paul, and take care. Good luck with
Thanks a lot,
everything.
Jeremy. Thank you very much. Pleasure to meet you.